Greetings. This video has to do with Module 4, which teaches us how to prepare smears. Now, it turns out the bacteria are almost always colorless, and they, of course, are very, very tiny. Because they're colorless, tiny, and don't really have good contrast with the background, they are very difficult to see using the microscope. To help us see them better, we need to give them color, which means we have to use stains. In order to stain bacteria, we have to first of all get them on the slides. Now, this isn't a trivial matter because it isn't just a matter of throwing a drop of bacteria on a slide and then staining it. There's more to it than that. You have to actually go through several steps to prepare what's called a bacterial smear. When you prepare a smear, it's important that the bacteria stick to the slide so they don't get washed off when you stain. And it's also important that they don't decompose after a few days of sitting on the slide. As you're going to see in a few minutes, smear preparation involves 3 steps. First of all, it's transferring the bacteria to a microscope slide, either from agar, like this plate, which has organisms growing on it, or from a broth, like this. You then have to let the bacteria dry for several minutes. Once the bacteria have dried on the slide, you then have to heat fix the bacteria on the slide. And we're going to see that heat fixation involves taking a slide and passing it through a Bunsen burner flame 3 or 4 times slowly. This procedure of heat fixation, fixing the bacteria to the slide, accomplishes 2 things. Number 1, it accomplishes them sticking to the slide. Number 2, it inactivates a lot of the enzymes that would otherwise bring about decomposition and breakdown of the bacterial cell over several hours or several days. Now, the reason I'm set up here to start off this module is I wanted to show you the details close up. So, of course, we first of all have to have microscope slides, and I have a box right here. And so I grabbed a couple of these glass slides out of this box. Microscope slides are 1 inch by 3 inches. They're made of glass, of course. And normally, if I were to just pull a microscope slide out of this box and then try to show it to you in this video, you would see it's pretty hard to see that slide. You really can't see the edges very well at all. I have a hard time seeing it just sitting here looking at the monitor. Now, if I pick it up and maybe move it over, you might be able to see it a little bit better. But at the end of the day, using video cameras like this, and given the resolution of this particular camera and the lighting, it's pretty hard for the video to pick up the edges of the slide. So what I did for the purposes of this video is I went ahead and before I turned on the camera, I set up a couple of slides. And what I did was I took a Sharpie, a black Sharpie marker, and I drew a line all the way around the 4 edges of these 2 slides. And so this really helps you see the slides better. You can actually see the outline of both of these slides. Now I'm going to show you how to prepare 2 different kinds of smears. Really, the only difference between the 2 kinds of smears has to do with the source of the bacteria. Are the bacteria coming from a broth, like this, which is simply a liquid that has nutrients in it, within which the bacteria are feeding and growing? Usually, not always, usually turning the broth quite cloudy. In microbiology, we refer to cloudiness as turbidity. So I would say, if I were speaking to another microbiologist, I would say this broth is turbid. The other possible source could be bacteria that are growing on the surface of agar. Now, they could be these bacteria, probably hard to see in this video, but I can actually see lots and lots of growth on the surface of this slant. Maybe if I hold it up just a little closer, you might be able to see. It's a little hard because the camera doesn't want to focus where I need it. But anyway, there are bacteria growing on the surface of the slant. This solid material contains nutrients, just like the broth, but it has agar added to it so that we can solidify the broth into what we call an agar. Another example of agar would be a plate like this. Again, it might be a little bit hard to see. Maybe if I hold it over here just a little bit where it's black, you can see that there are what appear to be white spots. Each of those white spots is what we call a bacterial colony, and each of those spots represents billions of bacteria. Again, these bacteria are growing on a solid surface, a solid substance. This solid substance contains nutrients and has agar added to it so that we can make it solid. So when it comes to smear preparation, there are two slightly different ways to prepare smears, and the differences depend on the source of the bacteria. If you are trying to stain bacteria and prepare a smear of bacteria that come from broth, you will make the smear one way. If you are using bacteria from a solid medium, like this slant, this agar slant, or the agar plate that I showed you earlier over here, you're going to prepare the smear in a slightly different way. Right off the bat, one of the differences has to do with how large of an area the smear will cover. When it comes to a broth, I usually draw a circle on the bottom underside of the slide that is about the size of a dime. It can be a little bigger, but I wouldn't do it much larger than a circle that has a diameter roughly equal to the diameter of a dime. If, on the other hand, I'm preparing a smear from bacteria that are growing on agar, I will take a microscope slide, and wherever I want to place the bacteria, I will mark it off with two parallel lines that make up about 25%, maybe 30% of the area of that slide. I'm going to just turn these slides around now, because normally when I work with slides, of course, they're horizontally oriented to me. So you can see on the right-hand side, or at least my right-hand side, there is a circle on the broth slide, and on my left-hand side, in the approximately the middle of this slide, there is a box that has been drawn in using two parallel lines, and that box equals about 25–30% of the area on the top surface of the slide. Now, one of the things you have to understand, usually when you make stains, when you do staining, the stains contain solvents, and we're not doing stains in this module, but we're preparing the smears to eventually do staining. So it's hard to separate smear preparation from staining, but you need to understand that when we do staining, we're almost always using stains that have solvents used to dissolve the dye. And those solvents do a good job of dissolving the dye. That's why we use them to make our staining solutions. But those solvents also do a very good job of dissolving and removing any Sharpie or permanent marker markings. Sharpie ink is resistant to a lot of different chemicals, including water. Water does not remove Sharpie marks very well. However, the ink that is used in the Sharpie is readily dissolved by any of the solvents used to make our staining solutions. So if I were to dip this in a staining solution and then take it out, all of the ink, or most of the ink, would start washing off. Now, this is a little bit of a problem, usually for students and sometimes for experienced workers like myself, in that sometimes it's hard to keep track of what's the top surface where you're putting the smear and what part, which side is the bottom surface where there is no smear. It's absolutely critical that you keep track of the surface of the slide that has the smear. I refer to the surface of the slide that the smear is resting on as the upper surface. This is important because if you put the slide in and the smear is upside down, and you put this into the microscope, you're not going to be able to focus on the smear after you stain it. It just isn't going to happen. In order to have any chance of focusing on a smear that has been stained properly, you need to have the upper surface of the slide, where the smear is located, facing up in the microscope. Well, how do you keep track of which side is which if the ink usually washes off? Well, there are a couple of approaches. One approach is to use what's called a grease pencil. And maybe I'll show that when I switch the camera over to the other island. But grease pencils, the mark left by a grease pencil is not readily dissolved by the staining solvents. So you can mark. What you could do is you could take your grease pencil and you could mark either the bottom surface or the top surface with grease pencil. I would recommend you mark the top surface so that when you are done staining, you'll know that the upper surface where the smear is marked with the grease pencil. That's okay. I've done that many times. My preferred method, however, is the second approach that I use in my lab, and that is to take a special diamond-tipped pencil. You use the diamond tip to scratch the glass slide. Now that scratch will not go anywhere when you're doing a staining. You can be 100% certain that when you're done staining, that scratch will still be there. Okay, so I think that's all I'm going to do at this station. Now what we'll do is we'll switch the video over and I will talk a little bit more generally about smear preparation, a little bit about staining, and then I will demonstrate how you prepare a smear from an agar culture and how you prepare a smear from a broth culture. Okay, so back. So I wanted to just kind of show you what I'm going to be working with here as I prepare my smears, as well as to show you some equipment that we're not going to use to prepare the smears, but that play a very important role in the staining process in later modules. So again, just a reminder, I washed my hands. I've already disinfected and dried the bench top surface. I have a white sheet of absorbent paper here that is only here for video purposes. I almost never do microbiology work at the bench with this white paper in place. Occasionally I will if I'm working with certain stains and I want to keep any spilled stain off the countertop. These countertops are very expensive and we try to protect them the best we can. So let's kind of look at the equipment here. First of all, the equipment that we're not going to use for smear preparation, sitting right in front of me, is this blue, cobalt blue dish. So this will be used starting in module 5 for the different stains that we're going to do. On top of the staining dish, we put this little metal rod and putting it across. It spans across the two edges of the dish, and it allows me to take slides that I'm eventually going to stain, and I can put those slides on that rod. Now, probably when I actually do the staining, what I'll do is I'll switch this blue dish for a clear, colorless dish, because in the colorless dish, you won't see the dish very well, but you'll be able to see the rod better and the slides on top of the rod. But we're not doing staining in Module 4, we're just doing smear preparation. So for this module, I just wanted to show you some of the equipment that we will be using down the road. So let's put the rod aside and the blue staining dish aside. I also happen to have a bottle of stain here. Again, we're not using this in Module 4. I think this is a stain we use in Module 5. It's called methylene blue, but we're not going to use that in Module 4. So let's put that aside. What that does, that leaves us with our necessary equipment. The two slides that I showed you earlier. The broth slide that has the little circle. The slide that is used for an agar smear that has the rectangle in the middle. I also have an inoculating loop. I have a bottle of distilled water if I need it. I have a plate that I showed you earlier that shows the bacteria growing. And then in this blue rack, I have the white cap tube with broth. This is the broth that we inoculated the other day in Module 3. You can see it has grown very well. This is E. coli. We also inoculated a slant with E. coli. This is the red cap tube from Module 3. And again, there is growth on the surface of the slant. Now, for purposes of this module, I'm going to make a smear from this broth, E. coli, and from this slant. Of course, in order to do that, I have to get started by firing up the Bunsen burner. Okie doke. There it is. It's burning away. So the way I typically do this, I'm going to show you how to prepare the broth smear first, okay? So again, here is the slide that we're going to use. I have outlined the edges of the slides with a black Sharpie marker. I have drawn a small circle the size of a dime on the undersurface of this slide. And I've labeled the slide broth, although I don't know if that is backwards on the video. It seems to me the video sometimes will reverse things so that they read backwards. But take my word for it, the word there is broth at the very top where my finger is. So I'm going to use this slide to make a smear from the broth culture of E. coli. This other slide I'm going to set aside for the moment, out of the way. Okay, so the first thing you do for the broth smear is you sterilize your loop. Now, as I demonstrated in Module 3, I'm going to be using aseptic technique here. I want to get the bacteria from this broth onto the slide, but I do not want to contaminate this broth with other microorganisms. So I need to handle this aseptically. In other words, I have to use a technique that will successfully transfer the bacteria from the broth tube to the slide, but the technique does not contaminate this broth with microorganisms from somewhere else, like the air, the countertop, or the slide itself. These slides are not sterile. There are microorganisms or spores perhaps existing on the surface of this slide. Once I touch this slide with my loop, it is contaminated with those organisms. So I don't want to touch, after I flame the loop, I don't want to touch anything, slide, countertop, lab coat, nothing, fingers. I don't want to touch anything with this loop, except for the broth that's in the tube. And then once I get this into the broth and come back out again, then I can take the loop and I can put it on the slide. So watch what happens here. It's cooled off. I pop the top. I flame the mouth. Now I go in and I get a loop full of broth. That's why we have a loop at the end, because you'll get a little film of broth there. I flame the top. I put this back down. And now what I do, I'm going to, I don't know if you can see this really well. Let me move this out of the way, I think. I'm going to touch that and leave a little droplet behind, okay? I've found that that's usually not enough. So, since I contacted the slide, this loop not only has E. coli on it, but now it has anything else on that slide surface. I don't want those other things from the slide surface, so I need to sterilize the last 1.5 inches or so of the loop. Doesn't show up really well, I know. Take about 15 seconds to cool. Now what I want to do is put a second drop of E. coli broth on the slide. Pop the top of the E. coli broth, flame the mouth, go in, pick up some of the liquid in the loop, flame the mouth, the top back on. Now that was legal because I'd already sterilized the loop. The loop was sterile before I put it in the broth. Now I touch it to the slide inside that circle and I leave another loop full of liquid. Now that looks like those 2 loopfuls are enough. So what I'm going to do is I'm going to sort of spread that around a little bit. And again, this is hard to see, I know. And I'm spreading it so it is it's creating a wet spot that is just a hair larger than the circle on the slide. The circle is a guide. You don't have to stay exactly within the mark that you put there. The reason I'm going to the trouble to spread it out a little bit is because if I don't spread it out, it'll sit there as a drop and it'll take forever to dry because the next step is going to be air drying this slide. I don't want to sit here for an hour. So I spread it out a little bit and that's it. I sterilize the loop again. And like I showed you in module 3, I then rest the loop on the stem. I rest the handle of the loop on the stem of the Bunsen burner. Now you might ask me, you might say, well, wait a minute. If you want to dry faster, why don't you spread it even more? Because it's still sort of sitting there as a small drop. Well, you could do that, but the bacteria in broth are few and far between. The broth is fairly dilute. And so if you spread this liquid too much, when you finally stain the smear, it'll be very hard to find the bacteria. So to make the bacteria easier to find after you stain the smear, it's better to keep the liquid that you put on the slide spread out as little as possible. That's why I start with a circle the size of a dime, and then if I need to spread a little bit more than that, I do to help it dry. Okay, so that has to dry in the air. Just put that aside for now. Now we need to do the slide that's going to come from the auger. The first thing I have to do is I have to get a couple of loopfuls of water inside the rectangle area. I keep trying to find a place where you can see this. Now, you could take your bottle, your squirt bottle, and you could squirt a drop. I don't have very good control of the water when I do that. I like to control the amount of water that I'm putting on. So what I do is I pop the top of the water bottle. I make sure that my loop, I'll heat my loop up again just a little bit, because I don't want to accidentally transfer any bacteria from the tubes I'm working with into the water. So the loop is now sterile. I'm going to go into the water, which is not sterile, by the way, and grab a loop full of water, touch the slide, leave that behind. I'll go back in again, because neither the slide nor the water is sterile, so I don't have to flame my loop in between here, right? And maybe I'll go back in one more time and put a third loop full. Okay, that's probably enough water, 3 loopfuls. Now, before I touch the bacterium on the slant surface, I need to sterilize the loop, because this loop has been contaminated by the water that wasn't sterile and anything on the slide, because the slide isn't sterile. So before I go into the culture of the slant, I need to sterilize the last inch or inch and a half of the loop. I wait about 15 seconds for it to cool. Now I'm going to grab the slant. This is the red top tube. Pop the top, pass it through. Now I'm going to go in and I'm going to get the smallest bit of colony of growth on my loop. This will not show up at all. You want to be able to tell that you at least got something on your loop. You don't want much. If you can see it, if it's really big, this isn't going to work. You don't want to put too many bacteria in the smear. Okay, so flame the top, back on. And now I'm going to take this little bit of bug. I'm going to do it over here where I can see it better. And I'm going to whooshel it around in those drops, those loopfuls of water that I put on the slide. And it turns out looks like I might have gotten a little more bug than I really wanted to, but I think this is going to work. So all I'm doing now is I'm mixing the bug that's on the loop into the water that I put on the slide, and I'm spreading it within that rectangular area. I'm actually going a little bit outside it. And there we go. Flame the loop again. Okay. Now I'm going to try to show this to you. I'm not sure how well this is going to work. Flame out of the way. Okay, I might get a little dizzy here because I'm going to move the camera up. Okay. So hopefully you can see, I think you can, if I don't get the glare on the slide, you can see the smear is still wet, but it's starting to dry around the edges. And against my black shirt, I think you can see that the smear has a hazy appearance to it. That's fine. Now, if I would have put too much material on that slide and mixed it into the water, it would be much, much cloudier, and it would be what we call too thick of a smear. A thick smear is not a good smear. It doesn't stain well. In order to have the most success staining a smear, the smear needs to be relatively thin. I think this is going to be just about right. I think when this is done drying, that smear is going to be obviously there, but it won't be opaque. It'll be just somewhat hazy. Okay, let's see how the broth smear is going. Now remember, this is just the first step, right? The first step is to get the bacteria, the proper amount, the proper number of bacteria on the slide first. That's the first step. The second step is you let the smear, and that's what it's called, once you've mixed the bacteria either with water on the slide, or you've mixed it, or you've just taken it from broth and you've spread it around, you have created a smear. So the first step is to actually make the smear. But there is more that we have to do to finalize the preparation of the smear. So after putting the bacteria on the slide, which is step one, step two is to let the smear dry in air. That's step two. Once the smear has adequately dried, and you can usually tell just by holding it and getting the light to reflect off it. This looks pretty good. I then have to do step number three, and the broth slide is ready, the agar slide is not. The broth slide is going to be heat fixed, and I heat fix by taking my Bunsen burner and passing the part of the slide where the smear is located through the flame 3 times. And I go through slowly, but not too slow. I don't want to boil the bugs. So the only way to do this is to show you, not just describe it. Okay? So here we go. There is a flame there, even though you can't see it. I'm going to take the slide, smear side up, and I'm going to pass this through the flame slowly 3 times. 1, 2, 3. What that has done is that it has heated the slide up enough to make the bacteria stick. You may have noticed I was tapping this against the back of my hand to make sure that it wasn't too hot. It shouldn't burn me. If I touch this to my skin just briefly and it feels like it's going to burn me, well, I went through the flame a little too slowly. And what that'll do is that'll distort the bacteria. They won't have their normal appearance, and you really need to just start over again. It's not even worth staining it because you'll just waste your time. You'll stain it, you'll look at it and go, oh, it didn't work. So I can tell you, if the slide is so hot that it's going to If you're like, wow, that's really hot, it burns, that might burn me. Well, it's too hot. It should be warm. It can be quite warm, but it shouldn't be so warm that it may feel like it could burn you. It's up to you whether you want to do that. I'm not instructing you to do that. I'm just telling you what I do. And after having prepared thousands of smears, literally, over my 40 years as a microbiologist, I have a pretty good feel for how slowly to go through the flame. Okay, so this smear, the smear from the broth, has been air dried and has been heat fixed. The smear at this point has been prepared. Now, you could immediately stain the smear, or you could store the smear in a slide box. If you were in the lab with me, I would have given you a box that holds 25 or 50 slides, and you could keep this in your slide box, because you see, once you have heat fixed the bacterium, it's not going to change. It can sit for an hour, a day, a week before you stain it. Okay, so that slide is done. That smear has been completely prepared. Now I'm looking at the agar smear, and this looks like it's dry. It dried pretty quickly. So let me go ahead and heat fix this, and then I'll show you the smear close up. So I'm going to take the slide, pass it through the flame 3 times slowly. 1, 2, 3. Okay, that's good. All right, so I'm going to stand up again. I want to show you a close-up of these 2 smears so you know what they look like. Okay, here's the broth smear. Now, it actually looks a little more cloudy than I think it is, but you can see it might be a tad hazy. If I get the light just right, you can see there is a film on the surface. That's your smear, air dried and heat fixed and ready to go. You can stain it or you can stick it in your slide box. The other slide, which is prepared from agar, there you go. Doesn't look any different, except it looks dry now. You'll notice it's dry and it's somewhat hazy. It actually looks thicker than it is. In real life, it's clear that this is a fairly thin smear, but just because it's thin doesn't mean you shouldn't see a hazy place or a hazy spot. So there you go. This is a properly prepared smear that has been air dried and heat fixed, and it too is ready to either put in the slide box till later or to be used immediately for staining. So that completes my presentation of Module 4. Now in Module 5, I'm going to take these slides and I'm going to stain them using the simple staining protocol that is described in your lab manual.